Today I'm talking about section 3.1 in our Algebra 2 text on page 118. And this is the start of the new chapter. The chapter is all about polynomial equations and inequalities with polynomials. So this first section is kind of an introduction to polynomial equations. So first off, just a reminder of what polynomials are. We know polynomials basically have multiple terms.
Are they supposed to get their person today?
No, not today. So a polynomial has just the terms in it. Something like x squared minus x minus 12 is a polynomial. We see the separate terms. There's three terms here. We see exponents that give us some information about the polynomial. And you recall that we were able to take these polynomials and break them down into factors in our factoring unit. So when we needed to factor it, we were able to break it down into what binomials multiplied to give us this one. So for example, we knew we could break down 12 and break down x squared, and we would end up with something like x minus 4, x plus 3 as the factors of this polynomial, okay? What we're able to do once there is an equation involved, once we put an equal sign after here, now we're able to solve these polynomial equations, all right? And so we've done this before in our quadratic chapter. As long as it was an exponent of 2, then we were able to kind of factor it in this manner and then solve the equation. What happens now is we're applying this to other polynomials, okay? We know poly just means more than one. But if we have a polynomial with a degree higher than 2, you know, what are some of our options to find its factors? All right, so the first thing we're going to talk about is the rational zero theorem on the bottom of page 118. And so it basically looks like this, and I'll move my toolbar over a little bit. And it shows us our rational zero theorem. And it shows us that every rational zero of a polynomial can be found by dividing the factors of the constant term by the factors of the leading coefficient. And so they're showing us that our rational zeros, meaning the answers, okay? The answers that are rational are equal to your P divided by your Q, where P stands for the factors of the constant term, which we know the constant is the one with no letters, right? Divided by the factors of your leading coefficient. That's the one in the very front, okay? So similar to how we figured out that 4 and 3 would be a factor, we had taken like, you know, what's the number here? Well, all you can do is 1 times 1, and then your factors of 12 were 3 and 4, 2 times 6, and 1 times 12. And we kind of selected what to put here. It's similar to that, but they've kind of simplified it for any polynomial, okay? That take the factors of the constant term, and I'll go ahead and write it here. It's in your book, but then you'll have it in your notes too. So the factors of the constant, I have to move my toolbar again, constant divided by the factors of the leading coefficient. Okay? And that's our rational zero theorem. So on the next page it tells us divide every factor of the constant term by every factor of the leading coefficient. Remember that when factoring the leading coefficient, only the positive factors need to be considered. Okay, we're not having to include negatives in that. If the leading coefficient is negative, then we'll factor out a negative one first from the whole polynomial before we even start listing the possible factors. Alright, so they're showing us kind of an example of that on page 119 where they have, I'll leave our instructions kind of there to look at. And they've got 2x squared minus 9x minus 5. And so we're looking at the factors of the constant term. This is our constant, okay? And so our factors of 5 pretty much are just, 1 times 5. But we know we could have positive 1, negative 1, positive 5, negative 5. So they're showing us the factors of the constant, which would be our p value, that p could be plus or minus 1 or plus or minus 5. For our q value, the factors of our coefficient of the leading term, here we've got 2. So then our q value would be plus or minus, only the positive, so just 1 and 2. Alright, so now we're going to list all of our possible zeros by taking all of the p's and dividing them by each q. So you can see they have the list of rational zeros, p divided by q. So let's say we start with, all of our 1's, right? So I can take positive 1 divided by this 1. I can take negative 1 divided by 1. And then go on to the positive 1 divided by 2. And the negative 1 divided by 2. Okay, so I've taken care of both the positive on each of these and the negative on each of those. Now I'll switch over to the 5. Well, I can have 5 divided by 1. I just got out of order there, sorry. This positive 5 divided by 1, the negative 5 divided by 1, and then the positive 5 divided by 2, and the negative 5 divided by 2. Okay? So just matching them all up. And then they just kind of simplify them to see what you get. Well, 1 divided by 1 is 1. This would be a negative 1. This is still 1/2. And so what they did is kind of put those together, that I see that I've got a positive 1, a negative 1, 1/2, a negative 1/2, a positive 5, a negative 5, a positive 5 over 2, and a negative 5 over 2. Hopefully you can see all this. I'll move it up a little bit. And so again, we're just taking the p's divided by q's in order, all the list, right? Oops. And now we're just going to simplify, kind of put them together. Well, I've got these two are the same. So I've got a positive and a negative. I can write that as plus or minus 1. I've got these two. I've got a positive and a negative 1/2. I've got a positive and a negative 5. And a positive and a negative 5 over 2. So these are all the possible rational zeros of this polynomial, okay? That's what they're going to have you doing in the first few questions of the assignment, is just to go in and list all the possible zeros. Again, keeping in mind you're doing the constant first, okay? The factors of the constant are your p, the factors of your leading coefficient are your q, and then you're just going to kind of find a pattern such you get them all, okay? So this divided by each of these, the positive and the negative, same thing, do the positive with each and then do the negative with each. Clean them up and get to your final answer, okay? So that's just the rational zero theorem on page 118 to 119. And I'll pause there.